Hello guys, so you know the 2025 AMC10A Problem 16. So there are 3 jars, each of whose 3 coins is placed in one of the 3 jars, chosen at random independently of the placements of the other coins. What is the expected number of coins in the jar with the most coins? So first of all, expected value is something like E of x is equal to 3 times the probability that 3 is the maximum, plus 2 times the probability of that 2 is the maximum, plus 1 times the probability that 1 is the maximum. And this is just how expected value works. Let's handle these case by case now. So case 1, 3 is the maximum. Then our jar should look like 3, 0, 0, where 3 represents how many coins are in that jar. So there are 3 ways to choose which coin has 3, and which jar has 3 coins in it. And out of there, we have 1 over 27 ways to put the coins in. So now we have case 2, which is 2. So now we have 2, 1, and 0 as our jars. There are 6 ways to arrange these. And in those, we have 3 ways to choose which coin is going to be in the 1 jar. It's now 1 over 27 to arrange them as well. Now last case, case 3, is that 1 is the maximum, which means that we have 1, 1, 1. And so from here, there's one way to just choose them. And then now the first coin has 3 out of 3 choices to go. The second coin has 2 out of 3 choices to go. And the last coin has 1 over 3 choices to go. So this is just 2/9. So now our total is just 3 times 3 times 1 over 27, plus 6 times 3 times 1 over 27, times 2, and then 3 times 2 all over 27. So let's cross things out. Wait, I don't know what that is. Let's cross things out. So this is equal to 1/3. This is equal to 1/9. So we have 1/3 plus 4/3 plus 2/9. And this is just equal to 17 over 9. And that means our answer is 17 over 9D. Hello guys, today I'll be going to the 2025 AMC10A Problem 17. So let n be the unique positive integer such that dividing 273,436 by n leaves a remainder of 16, and dividing 272,760 by n leaves a remainder of 15. What is the tens digit of n? Alright, so first of all, we know that 273,436 is equal to 16 mod n. And 272,760 is equal to 15 mod n. This means that, let's subtract these two numbers. This gives us 676 is equal to 1 mod n. So 675 is equal to 0 mod n. So what does this mean? This means that n is, this means that n is equal to some number that's some one of 675's divisors. And so this would be 1, 3, 9, 27, and 5, 25, and some overlap of these numbers as well. So now let's look back into this. Let's first look at this bottom equation. 272,745 is equal to 0 mod n. Let's first divide by 5 and see what happens. Dividing by 5, we get 5. Actually, yeah, let's just draw the dividend. So we get 5, 25, 22, 4, 5, 4, 9. So 5, 4, 5, 4, 9. Obviously, this is not divisible by 5, so n can't be 25 or any multiple that has 25 as a factor. So that's interesting. And on top of this, let's also view 27. We have 272,745. Let's divide by 9 here. We get 30305. 30305 is not divisible by 3 because of the sum of digits rule. 6 plus 5 is 11, which is not divisible by 3. So 27 can't be a divisor. So now we're left with this pool. And we know that since n has a tens digit, we can automatically eliminate the ones with 1 digit. So the only ones we have left are 15 and 45. That are 2 digits. And obviously, since it has a remainder of 16, it can't be 15. So our answer is 45, tens digit 4. Hello guys, so you go to the 2025 AMC10A Problem 18. So the harmonic mean of a collection of numbers is the reciprocal of the arithmetic mean of the reciprocals of the number in the collection. For example, the harmonic mean of 4, 4, and 5 is 30 over 7. So what's the harmonic mean of all the real roots of this 4,050th degree polynomial? So our number is going to be 1 over, there's 4,050 roots, times all the roots reciprocals. And so now let's take them all under a common denominator. This will be all the roots multiplied together, and then over R2, R3, plus R1, R2, so something like that. And so we know that by Vietas, this is the constant term, and this is the term with degree 1. And so now let's take a look at this equation. So the constant term will be negative 3 to the 2025, because we can just multiply every single constant. And since it's a 4050th degree polynomial, we have to negate this. So this is 1 over 4050 times the constant term is 3 to 2025. So now what's the subconstant term? We can achieve a subconstant term by, let's say, taking negative 4x and then multiplying it by every other negative 3. So what would that be? That would be negative 3 to the 2024 times negative 4. And since there are 2025 4 terms, this is 2025. So now this is going to be our answer all over 1. So this will be negative 3 times negative 3 over 2. Wait. So no, this is not negative 3 over 2. This is negative 2 over 3. And so taking the reciprocal, this is negative 3 over 2, which is our answer. Hello guys, you can go to the 2025 10A problem 19. So an array of numbers is constructed, beginning with the numbers negative 1, 3, and 1 in the top row. Each adjacent pair of numbers is summed to produce a number in the next row. Each row begins and ends with negative 1 and 1 respectively. As the process continues, one of the rows will sum to 12,288. In that row, what is the third number from the left? So the sum of the first row is 3, the sum of the second row is 6, and the sum of the next row is 12. So we know that the sum of row n is going to equal 3 times 2 to the n minus 1. And so since 12,288 is equal to 3 times 4,096, this is just row 13. So we want to find the third number from the left in row 13. So let's take a look at this. So we have 1, 3, 1. Then the next row will be 1, negative 1, 2, and no, negative 1, 0, and 2. Then after that, negative 1, negative 1, 2, negative 1, negative 1. Wait, cut that out. Alright, so now we have negative 1, 3, 1. After that, we have negative 1, 2, and 4. Negative 1, negative 1, 1, and 6. Negative 1, 0, 7, negative 1, negative 1, 7, negative 1, negative 1, 6. No, negative 1, sorry, negative 2 is here. Negative 1, negative 3, 4, negative 1, negative 4, 1, negative 1, negative 5, negative 3, negative 1, negative 6, negative 8, negative 1, negative 7, negative 14, negative 1, negative 8, negative 21, and negative 1, negative 9, negative 29. This is going to be our answer. Hello guys, so I'm going to 2025 10A problem 20. So a silo, right circular cylinder with diameter 20 meters stands in a field. McDonald's is located 20 meters west and 15 meters south of the center of the silo. McGregor is located 20 meters east and G meters south of the silo. The line of sight between McDonald and McGregor stands in the silo. The value of G is A root B minus C over D. Find A plus B plus C plus D. Alright, so this is kind of what our graph is. We have 20 over here and 20 over here. We have G over here. We have 15 right here. And so now we know this is the radius is 10. So now we can do a little bit of quick maths. So let me erase that line real quick. Basically, let's make this line right here and this line right here. Now these are both 90 degrees. So now we know this is 10. So now we know that this angle is equal to 400 plus g squared, square root of 400 plus g squared. And this length is equal to square root 625. So now by Pythagorean theorem, we know that these two purple lengths is going to be equal to square root g squared plus 300 plus square root of 525, just by Pythagorean theorem alone. Now, how else can we express this? let's move this length of 20 up. So now this red length is 40, and this length is 15 minus g. So by Pythagorean theorem, this purple length is also equal to g squared minus 30g plus 225 plus 1600. So we know that, and the square root of this. So now this is equal to g squared plus 825 plus, by FOIL, 2 root 525 times g squared plus 300. We can cross out. This leads us to negative 30g plus 1000 is equal to 2 root 525 times g squared plus 300. So let's divide by 2 on both sides. Negative 15g plus 500 is equal to 525 times g squared plus 300 times g squared plus 300 and the square root of that. So let's square both sides. Now we have 225g squared minus 15,000 g plus 250,000 is equal to 525 g squared plus 525 times 300. So now we have 300g squared. Let's subtract these on both sides. Plus 15,000g. And now let's divide by 100. So 100, 100, 100. So now we have 3g squared plus 150g minus 2500 minus 525 times 3. So now what is that? That's negative 925. So hold on, let me just add a page. We want to find g, since that g is the solution to 3g squared plus 150g minus 925 is equal to 0. So by the quadratic formula, this is negative 150 plus, obviously can't be minus, otherwise g would be negative, and 150 squared plus 4 times 3 times 925, all over 6. Let's first factor out a 4. Let's first divide by 2. This is negative 75 plus, now we have to factor out a 4 from the inside, which would make this 75 squared plus 3 times 925, all over 3. Now let's factor out a 5 from the square root. Negative 75 plus 5 root 225 plus 3 times 925 divided by is 37, all over 3. So now 3 times 37 is 111. And so adding this together is 336. So negative 75 plus 5 root 336 over 3. Now we know that 336 is equal to 16 times 21, so we can factor out a 4. So this is our final answer, and this means that 20 plus 21 plus 3 plus 75, which is equal to 119. Thank you guys for watching. If you enjoyed this video, make sure to like and subscribe, and peace.